There are 323 bags of salt waiting to be transported across the Sahara Desert. What is the minimum number of camels needed if each camel transports the same number of bags at the same time, but no camel can hold all 323 bags at once? Alright, well this is just a matter of finding the factors of 323. Because you know, if this was like 10 bags, and no camel could hold all 10 bags, then 10 is 2 times 5, so the minimum number of camels would be 2, and each camel would hold 5 bags, right? So, but we're not dealing with 10, we're dealing with 323. So let's look at 323 and try to find the factors. That's the hard part of this problem, is just finding the factors of 323. So let's go through our divisibility rules. Now we know it's not divisible by 2. Let's look at each prime number. It's not divisible by 2 because it's not an even number. If in order for it to be divisible by 3, the digits have to add up to something that's divisible by 3, right? So if I take 3 and 3 plus 2, that's 8. That's not divisible by 3. So the whole thing is not divisible by 3. Okay, 5. A number that's divisible by 5 has to end in 0 or 5. So it's not divisible by 5. Okay, we can check that off. Next prime number is 7. Okay, there's not really a good rule for 7. There is a rule, but I know for one I can never remember it when I need it. So sometimes it's just easier to divide by 7 and see what we get. So let's see, we can multiply 7 by 4 and get 28. Subtract that and we get 43, and then we could take it, 6 times 7 is 42, so you can see we get a remainder of 1. So it's not divisible by 7. Alright, well, the next prime number is 11. Is it divisible by 11? Well, you could either divide it by 11, or you might know the rule where if you take a number and you add the alternate digits and subtract, if you get 0 or a multiple of 11, then it's divisible by 11. So here's what I mean. So the alternate digits here are the 3 and the 3. Okay, so we take every other digit essentially. And so 6, and then the other digit, there's only one of them, is 2. If you subtract those, you get 4, which is not 0, and it's not a multiple of 11, so it's not divisible by 11. Another thing that's interesting about this, for 3-digit multiple 11, at least by this rule, is that you can see that the first and last digits have to add up to the middle digit. Okay, so if it's a 3-digit multiple of 11, the first and last digits have to add up to the middle digit in order for this to work, right? So that's not the case here. Alright, let's go to the next prime, which is 13. Let's see if it's divisible by 13. Well, there's no real good rule for 13, so let's just divide by 13. 323 divided by 13. Okay, well it looks like this will go in twice. So there's 26, and we can 6 left over, drop the 3. 63, let's see, I think the closest we can get, if we multiply by 4, we get 52. And then we have 11 left over, so we have a remainder of 11. So it's not divisible by 13. So this gets kind of tiring, right? So let's keep plugging away. The next prime number would be 17. So let's try dividing by 17, see what we get. 323. And so that'll go in once. And so 32 minus 17, that gives us 15. Drop the 3. And it turns out if we multiply this by 9, we end up with, carry the 6, so we end up with 153. Woohoo! Alright. 153 with no remainder. So 323 is equal to 17 times 19. Okay? So we're looking for the minimum number of camels. So we can either have 17 camels carrying 19 bags of salt, or we can have 19 camels carrying 17 bags of salt each. And the minimum number is 17 camels.